I have found that in our work here that we're having a hard time getting kids to move away from skip counting or repeated addition into thinking multiplicatively. And that's one of our challenges is how do we do that? How do we get kids to think in groups of? And so I think that's our continued work.
And that's noted in the research.
Yeah.
They're not moving into multiplicative thinking and have that big idea of unitizing as an underpinning in their understanding of the mathematics. I think that's been our dilemma as well. Can we recognize when kids are showing additive thinking? And then as we all learn about multiplicative thinking, can we label it? Can we recognize the strategies that kids are using? What tools or models would help them reason through a task and represent their thinking? That's my ongoing struggle.
If there's 3 groups of 3 and they're going 3, 6, 9, or they're going 3 groups of 3, 3 times 3, or if they're going 1, 2, 3, 1, 2, 3, 1, 2, 3, then that's additive, right?
And it's also, it's about the addition and multiplication about finding the total count.
Yeah.
So if you see 3 groups of 3, you're thinking, oh, wow, they're thinking multiplicatively. 1 group of 3, 2 groups of 3, 3 groups of 3 is 9. But when you go back and ask them, how did you count?
That's right.
They go 1, 2, 3, 4, 5, 6, 7, 8, 9.
Yeah.
And then you use wait time, and then you say, how many? And then they go 1, 2,
So they don't trust
3.
the count.
They don't trust
Yeah.
the count.
Adam was saying that for when he did this question with his class, that there was 218, so they drew 21 boxes of 10.
Oh. And
So
then 8 boxes?
to me, that means that they're unitizing, so they're thinking in groups of, but they're thinking additively because they had needed to draw the 21 boxes to. I don't know if you
Depends how they're using the boxes, right?
That, I agree with Vanessa. It depends on how you're using the boxes.
in that situation where you were with when the kids drew the 21 boxes, did they show or were you there to monitor?
I was there. I asked them, and they were counting by tens.
They were counting
Yeah,
tens.
they just were drawing out everything.
So then wouldn't that still be additive thinking though? Because they're doing 10,
Plus 10.
20, 30. They're not doing 10 times 10. Additive, yeah.
I found with some of the students, though, they'll, in their head, they will think multiplicatively. They'll think, okay, well, that's 6 times 3, so that's 18. Okay, great, can you show me how you did that? And they'll say, oh, well, I need to show the work. Okay, well, I did 6 times 3, so that's 6 plus 6 plus 6. And they'll show it additively, even though maybe in their head, they did it multiplicatively.
So how did you know you needed 9 boxes?
Because the tens number was 9.
So what was left over?
7.
7. And how do you know that?
Because the 7 is in the ones column.
So I had to prompt him to say, well, can you show me? Show your thinking. I'm like, what does that look like? He struggled trying to represent his work, though.
Yes.
Yeah. He didn't understand, like, what do you mean? He looked at Celine and said, oh, okay, so I have to draw the boxes with the chocolates in them? Like, he had a hard time being able to represent his work.
They almost felt obligated to represent their thinking, but it wasn't actually an accurate representation of what they were doing mentally. I'm not sure how we remedy that situation.
So what I did was 102 times, and then I did 10 one time, and then I added the 8, and then it did equal 218.
How many boxes?
21.
Where did you come up with 21?
Because when I got to 100, it did take me to 10 boxes, and then I knew that another 100 would be another 10 boxes, and then the 10 brought me another box, and then the 8 didn't bring me a box.
He did his facts, but he knew he needed 21 boxes with 8 left over.
And then what is our role? How do we get them over the hump? What kinds of questions do we ask? What kinds of tasks will help move kids along?
Okay, so you said I know another efficient way. So what's your efficient way? That was a good job, bud.
10 times 4 plus 4.
Okay. So what made you do that?
So I know that like 10, like I count by 10s and stuff. And so I had 10 and then I times 4.
Okay. And that gave you what?
That gave me 40 and then I have to add another 4. So I plus 4. And then equals.
How do we value that, and how do we show them
By
that we
asking
value
them to make a connection. What we need to do is help kids make connections between their thinking, somebody else's thinking, and put an emphasis on the multiplicative thinking.
And making connections across the representations, that
Exactly.
they're all equivalent. Like if the goal was to figure out 3 times 4, and one did an array, one chose to represent in terms of equal groups, and someone did repeated addition, that they're all going after the same thing. So having a conversation about how are these representations the same but different.
So that
is
speaks to how important and when we sequence and we select.
Ryan and Ross worked together on this. So Ryan, yours is the blue underneath here. I want to know, how did you use Ross's numbers to make your number sentence?
Because I used the 10s, like all of either 10s, and I did it a more efficient way by doing 10 times 9, so I don't have to do like 9 10s in a row. I did it a more efficient way by doing multiplication and not addition.
What you're saying is that we need to honor that multiplicative thinking by highlighting. That's right.
Including the evidence in the monitoring to support, so not just base our decisions of selection on the product, but making sure that
from
we
the notes of
include
it.
the observations and conversations that we make during the monitoring to support those product pieces.